So top new CNCF projects to look out for is the topic for today. I'm very excited to be talking about this to you. Cloud native tech as well as Kubernetes is super close to my heart. So very nice to be here talking to you about this. So I like to start every one of my sessions with a little bit of kind of what value do you get by attending this talk, essentially, as well as, okay, what are the learning goals for this session as well. So there's two goals or two kind of value that I hope that people get out of this talk. Obviously, you can get other things as well, but these are the main ones, in my opinion, is to get inspired and to get to know cool CNCF projects. So this session is not a deep dive into any of the projects or any open source projects per se. It's more of a gonna introduce you to multiple different CNCF projects that you can then do a deep dive on to yourself when you have the time, and you can follow the step-by-step guides and everything. But today my aim is to introduce really cool projects in a very short amount of time. So I hope we're gonna meet that goal as well. So really nice introduction in the beginning as well, but just then briefly again, who am I and why am I speaking about these kind of topics here? Well, I am, as mentioned, a product marketing manager at Cast.ai, which is a Kubernetes cost optimization company, but I am also a CNCF ambassador as well as an Azure MVP, which means that I do quite a lot of talking, and it is my passion to talk about these cloud native topics, so I'm super happy to do it. I've also been organizing the Kubernetes and CNCF meetup for Finland for over 4 years now. I'm a startup coach. I coach early stage startups, as well as I host and produce the Cloud Gossip podcast as well. So very much Kubernetes, cloud native tech, all of these are very close to my heart in general. Then I think if people are now wondering, what is CNCF? What is Cloud Native Computing Foundation? Well, I'm here to answer that question. So CNCF mission is to build of sustainable ecosystems for cloud native software. So CNCF is part of the Linux Foundation, and it hosts critical components to the global technology infrastructure, as well as organizes large open source events like KubeCon, for example. And it's the home to Kubernetes, Prometheus, a lot of these cool, interesting techs, and actually home to a lot of other projects as well, which are a lot less known. Hence why I am here today introducing to a few of them as well. But then I think the impact of cloud native technologies, containers, Kubernetes, and these kind of things is relatively widely known. Everyone has kind of seen the impact around the tech world, but I think it stands to reason to mention these things and just as a kind of recap. So these sets of data, not data per se, but like stats are from CNCF 2020 survey, which is the most recent one that's been published, which is a survey that CNCF does every year that looks into the adoption of cloud native tech around the world. How are people using it? What are the pain points that they're experiencing, and what's the adoption level at that moment? And the use of containers in production has increased to 92%, up from 84% from last year during the survey, and up 300% from the first survey in 2016. And Kubernetes use in production has increased to 83%, up from 78% last year. So it's definitely a big household name, and it's here to stay as well, it seems. So cloud native tech landscape is big. And then you might be wondering, how does the landscape then look like? What is the CNCF world? What does all this look like? Well, this is how the cloud native landscape look like. And it is quite a lot. If you're seeing it for the first time, it's way too much info. Even if you're seeing it for the X amount of time, it is quite a lot of info in a short space. But no worries. Just understanding this thing, it's going to take days. One could talk about this for days, weeks, and whatnot, the whole thing. So we're going to take a bit of a simplified view today. So no need to worry about all the little minute details in this very scary looking graphic. So for a bit of a more simplified look, there are 3 stages to all CNCF projects. So there's the sandbox phase, there's the incubating phase, and there's the graduated phase. So if an open source project joins the CNCF, so becomes a CNCF supported open source project, they start usually in the sandbox phase. which is, they are early on, they're not, there's not too many maintainers yet, contributors and whatnot, but when they mature and they get more and more of everything, essentially, more maintainers, more contributions, more features, they move on to the incubating phase, and from there they move on to the graduated phase as they mature even more. And just to give you an idea, sandbox phase has around 50-40-ish projects within it. Incubating phase has around 20-30, and the graduated phase 15, 16, 17-ish. The space is moving constantly. Projects are moving forward quite a lot, quite often, which means that it's really nice because the industry is maturing as well. Another view into this would be that, you see here in the sandbox phase, it's the innovators, techies are adopting the tech, and then you move on to the incubating phase where the early adopters, the visionaries, are adopting it, and then you move on to the graduated phase where the late majority or conservatives are adopting the tech as well. And I think a good example of how the space is moving as well is the fact that a few years ago when I started talking about these things, there was only 1 or 2 projects in the graduated phase. So there's constant kind of movement within the projects there. And then moving on to the project in this session, as well as a bit of expectation management. So this session and the projects within it, I would love to know the future exactly. Like, it would be amazing if I knew exactly what's going to happen. I do not know, nor am I a fortune teller. So I cannot predict exactly what will be the top new ones per se. But the selection that I've used here is projects that I'm excited about and what people around me are excited about, and projects that are really garnering a lot of attention, as well as good communities around the projects. Because I think particularly for open source projects, to be really truly successful, having all of those components in is very crucial. So that's why it's kind of the method that I've used here to select these projects here. And as an expectation management, usually CNCF does intro to project talks are around 30 to 45 minutes in length. And this is a shorter talk covering much more projects than one. So as I said before, not a deep dive into any of these, more of a brief look into a lot of different projects. I will be covering Linkerd, Keda, Flux, Kudo, and Meshery today. So I update the session frequently as well. So if you've seen the session before, these might be new ones. I will update it for the next sessions that I do it the next time as well. And these are all different levels. So Linkerd is a graduated, Keda, Flux are incubating project, and Kudo and Meshery are sandbox projects. So there's a bit of everything for something for everyone. So even if you are, you need something that's very late stage, very production ready, you can go ahead with some of the tips that I give you, or if you are more in an experimental phase, you can get started with some of the sandbox projects that I'm talking about here today. But let's dive right into it. So Linkerd is the topic for now, the first project that I will be talking about. So it is the first service mesh, actually, and it's a service mesh as mentioned before. So it's ultra light, ultra fast, and security first service mesh for Kubernetes. And the overall goal of Linkerd is to really reduce the mental overhead of having a service mesh to begin with. It's a very community-minded project, a really great community there. And it's a really good project. As mentioned before, it is graduated project very recently, though, a couple months ago or so. And what does Linkerd or service mesh do? It provides observability. So it provides those service level important metrics as the success rates, rate latencies. In addition to that, it provides reliability. So retries, timeouts, and everything, as well as security as well. So then what are the benefits of Linkerd then kind of? So, or what is it, how is it built? So there it is, as mentioned, they have a very thriving open source community that's very welcoming. It has a simple and minimalist design, so no complex APIs or configuration. So for most applications, Linkerd would just kind of work out of the box. That's the design here. It has deep runtime diagnostics, so you can get a comprehensive suite of diagnostic tools, including automatic service dependency maps and live traffic samples as well. And you can also, it's ultra light and ultra fast, so it's built in Rust, and the data lane proxies are small and very fast. And it installs in seconds with zero configuration. And it also has actionable service metrics. So as mentioned, it has those. You can monitor golden metrics such as success rate, request volume, and latency, and so forth. So what are the principles then? It's just kind of, as mentioned, it just kind of works. That's the main goal here. It's ultra light and ultra simple. So as mentioned, it's kind of the bare minimum of service mesh in a way, but that's why it's also super light and simple and easy to use. It's security first, so it's not a default or an extra. It's a default, not an extra. And Linkerd has its own proxy. It's not using Envoy, which is another CNCF project, but it's using Linkerd 2 proxy. So this makes the foundation more secure and kind of custom as well. So comparing to, for example, Istio, it has a heavy focus on Kubernetes as well as just, being the bare minimum, but then just being very simple and easy and light to use. Yeah, and then how do you use Linkerd? How does it work? You just inject this and that's it. So when I mentioned easy and simple and light, it really is. So that's very nice. Then, now that we've covered one project, we're going to hop right on to the next one. I said this is going to be very fast. So here we are. We are now going to talk about Keda, which is Kubernetes event-driven autoscaling. So if you're wondering what is Keda, what the problem the Keda is solving is, so Kubernetes, default Kubernetes scaling is not really well suited for event-driven applications. And Kubernetes is more for resource-based scaling, so CPU and memory and so forth. But at the same time, you do need that, event-driven autoscaling at some point as well, and it's really great. So this is where Keda comes in. So Keda is event-driven scale controlling that can run inside any Kubernetes cluster. And then also what this means that it can monitor the rate of the events to preemptively act before the CPU is affected. So this is where the kind of magic is as well. And you can install it to new and existing clusters. It's extensible and pluggable scalars to grab metrics from multiple sources as well, which is super nice. So the Keda principles are essentially not to rebuild anything that Kubernetes offers out of the box. So it's different from the Kubernetes autoscaler. And it's single purpose, simple, non-intrusive, and works with any container and any workload. And today I'm going to be doing a quick Keda demo, which is scaling .NET Core Worker with Azure Service Bus. And you can here see the architecture of this very simple demo app from Keda. But you can kind of imagine that that very abstract architecture here, it's essentially just a web shop. So for example, Halloween is coming up, people are going to be ordering a lot of Halloween masks. So you need, if your web shop is running a web shop, you might have a bunch of orders at the same time, and you need to manage all of those orders and get them or processed. So as you can see here, there's an order processor, there's orders queue and whatnot. So it's a fast and really cool, nice demo in my opinion, at least. So let's get to it. We're gonna open up now the terminal here. So we're gonna go and get my notes because I will make gazillion typos if I were to not use notes. It would be absolute horror show. So then we're gonna do kubectl get services namespace Keda.NET sample to here. And this is where we get this a bit too small. There we go, that's better. So in here we get the external IP that I've already actually inputted to here. You see on the right. So we can show again. So in here you see the order portal. So you see the order queue length, you see the number of messages, the order queue. So when we're gonna start getting all of the Halloween masks orders coming up in one bunch, we will then see the orders spiking here. And then to get a bit more visibility, because we want to actually know what's happening, the demo is very fast. So we want to have full visibility while we're doing it. So we're going to do this kubectl get deployments here. So we can see, okay, how many order processors we have ready to process all of the orders. And then to get a bit of a look into what's happening in the history here, we're going to do kubectl get pods namespace Keda to here. So there we see that, well, 14 days ago, I've done this demo and whatnot, but then we're going to see here when the order processors are being created and all of this stuff is happening. So if we do then here .NET run project KubeCon demo, because I did this in KubeCon as well, Then we're gonna see, let's queue some orders. How many do you want? So this is this situation where all of the orders are gonna come in bunch. So a lot of people want Halloween masks out of the sudden. We need to have a solution that's scaling up and down when we need it to. So we have 100 orders queuing coming up. We see a lot of them happening. It's a bit too maybe zoomed in, but we see that, you know, there's a chicken, hat, pants, all of these orders are coming in. And then we see here the orders are spiking, they are going up. And then we see here that how many processors we have ready, not that many yet, but in here we see that it's pending, it's starting container creating as well. So we are getting there, and now it's container creating quite a lot. So we can now see 4 out of 4 order processors ready. This isn't anymore creating new orders, but this is going, this went to peak at 100, but then it's now going actually down because we are doing a wonderful job of managing all of those orders that were coming in super fast. And now after we're done creating, now it's just running to process the orders, and we are at 8 out of 8 in this side. So now as the orders are going down, we're still running and we're still managing these things. So Keda is still making sure that we can get through this orders. But then eventually, after all of this has finished and the peak has gone, Keda will start terminating all of the order processors. So then we get to the part where actually it's downscaling all of these things. So why is this super important and wonderful? Well, it's because, for example, if you are managing cost within your clusters, in this situation, if you are, you know, peaking when it's needing, auto scaling up and down, you are not wasting any resources. So you are actually doing very well as far as cost management goes, as well as natural resources. So you're cutting down on cloud waste. So you're being environmentally friendly as well, which is, I think, always a bonus as good as well. So that's how it works. It's going to take about 5 minutes for it to start terminating. So we're not going to wait until then. If we have the time, we might check up on it later, but let's continue with that presentation while Keda is working on terminating all of the order processors. So then moving on to the next one, the next project. So that's Flux, which is the GitOps family of projects. So what is Flux and what is GitOps, if someone's wondering right now? So it is one of the most mature developing technologies in the cloud native ecosystem. So according to the CNCF technology radar, which is a great resource for finding out what kind of tech should you be utilizing in this space as well. And then the project has a lot of good end users, and it really goes to the question of what is GitOps. So you have all of these commands, so CLI tools, kubectl apply, kubectl set image helm upgrade, kubectl upgrade. You can actually replace all of these with one CLI tool, which is git push. So it's really good because, well, Git is very widely used and widely known. And then instead of changing the state of your cluster with multiple things, you can use one command to modify something and push it to the Git repository, and therefore it ends up in the cluster as well. So this can be anything from namespace and so forth. So another reason why you might want to use this is that if you haven't used Git, you have a nice history of what has happened to the cluster as well. And GitOps really provides one model for making infrastructure, apps, and Kubernetes add-on changes, and you have consistent end-to-end workflow across your entire organization as well. So what this really means in a nutshell is that you have an easy snapshot of your cluster that you can restore to. So if anything happens. So if you lose your cluster, you just plug your new cluster to Flux and you restore everything. So now no stateful sets or databases and so forth, obviously, but everything that was in the Kubernetes memory essentially will be restored. So you have a desired state that's saved in Git and not the actual thing, but the desired state. So you kind of go back to that save point in a way. So why is Flux then great for GitOps? So Flux has an aim to be to provide a complete continuous delivery platform on top of Kubernetes and supporting all the common practices and tooling, for example, customized Helm, metrics, and Prometheus, and so forth. And as I said, it is recommended by the CNCF technology radar as well. Yeah, so what are the practices and benefits continued? It helps you describe your system declaratively. It can keep configuration under source control and use software agents to reconcile and ensure correctness as well and alert for drift. So the benefits there are then collaboration on infra, access control, auditable history, drift correction, and clear boundaries between dev team and Kubernetes. Hopping on to the next project, second to last. So no worries, we've gone through a lot already, but we are nearing the end. So as Flux and Keda are incubating projects, then Kudo is a Kubernetes Universal Declarative Operator, which is a sandbox project. So it's very early on project. And Kudo really goes into this stateless versus stateful app. So if all apps were stateless, everything would be really simple in the Kubernetes world, but not all apps are. So stateful app needs logic, specific knowledge to run a certain application. So Kafka might differ from Cassandra and so forth. And Kubernetes has been very focused on stateless, and stateful apps do not really play together with it all the time so nicely. So for this, the solution was stateful sets, but it doesn't really solve the fundamental issue there. So operators were introduced as a new solution. So operators are really great, but they manage and monitor the life cycle, but it takes a lot of custom knowledge to build one. So you need extensional, like a lot of deep expertise, you need thousands of lines of code, so substantial engineering resources really needed to do them, which means that it's not really an option for a lot of people. So this is where Kudo, the Kubernetes Universal Declarative Operator, comes in. So rather than using a custom operator and using operator framework or kube builder to build it, Kudo provides a universal operator with the concept of the plans built in. So the benefits then are that you can create operators without needing deep knowledge of Kubernetes or coding by just defining the lifestyle stages and just use Kubernetes APIs. It's a lot easier to learn, and it has Kubernetes native management, aka you can use kubectl to manage it as well, which is really great. Then to the last project that we're going to cover very fast. It's a sandbox project as well, so it's early on. So it's the service mesh management plane. So we talked about Linkerd in the beginning. We talked about what is a service mesh. So then now we get to, like, if you end up in a situation where you have a bunch of service meshes that you have to manage, because if you have, for let's say legacy reasons, personal preference of team members, you have to have multiple service meshes, like you have Istio or Linkerd and whatnot working in the same cluster. It might not work as well as you would want. So then when a normal service mesh is control plane and data plane, then Meshery introduces management plane to be service mesh management. Yeah, so then it really provides federation, integrates with backend systems, and may help perform chaos engineering, deeper insight into the performance, and honestly, a long list of things to do. So honestly, at the same time, even though Meshery is actually a very new sandbox project, it entered the CNCF just a few months ago, 1 or 2 months even. It's actually doing very well. So it has already 15 maintainers, over 300 contributors, and it's the most popular project in the Linux Foundation mentorship program. And Meshery also supports over 10 different service meshes. It has multi-mesh management, lifecycle workflow, performance, configuration, patterns and practices, chaos and filters. And it's not fully, it's not at the complete architectural level. So it's about halfway to complete to version 1. So it's still very early on. Now that we have done a few projects, run through them. I know this session is very intensive at the same time, but I hope that everyone can get a few projects that they can then do a deeper dive into themselves. So we have gone through a CNCF overview, we have gone through Linkerd, Kudo, Flux, Keda, and Meshery as well. I always love to give a lot of learn more resources, so you can check out the CNCF survey, you can check out all the project sites for more info on them. They usually have step-by-step getting started guides. You can support your favorite project in GitHub, always recommending that to always. If you want to learn more about the business side, you can check out CNCF case studies. For example, the Babylon and the ElfChef one have these projects that are mentioned today included in the case studies. If you want to learn how people are using them in production. And then I mentioned the CNCF end user technology radar. And if you want to dive deeper into what will the future of cloud native landscape look like, the technical oversight committee chair, Liz Rice, usually does a KubeCon session called Predictions from the Technical Oversight Committee. Always wonderful to learn more about this. And if you want to more beginner resources, Tech World with Nana has a lot of good ones in YouTube, and then CNCF YouTube has usually a deep dive into all of these project sessions, like kind of 45 minutes, 30-minute session into all of these projects. So I highly recommend checking them out. If this was too many links to memorize or take pictures or take notes in one go, I totally understand. Hence why I always add the link and slides to my GitHub so you can find them from there. If you want to learn more about open source project management, you can check out the podcast that I did with Tom Kirkhope, the maintainer of Keda. He went very candidly into how does he feel, what does it mean to be an open source project maintainer with CNCF. Very interesting stuff. I was very happy to talk with him on these. And then last but definitely not the least, I hope that one thing that everyone can take away is that everyone gets a bit of inspiration into, as mentioned in my description, either to be the coolest kid in the block and knowing the coolest and the greatest new project, or actually getting something to use in your next tech project. I'm always happy to answer any questions in Twitter or LinkedIn as well. So happy to see people reaching out there as well. But thanks.